Unit rates. All right, this is a very important lesson because if you're ever going to be a shopper, buying the best deal, finding a good deal on a car, anything like that, you're going to want to know this lesson, unit rates. We are in the M2-T1 ratios tab. If you're in OneNote, you're looking for the one that says Introduction to Unit Rates, what's the best buy? And if you're working in your textbook, you are looking for, we're skipping ahead a little bit, M2-185. That's where you want to be for that one. Introduction to Unit Rates. Okay, let's skip this getting started. Well, let's look at it really quickly, and I just want you to ponder this while we go through. Which one would you buy? Marta and Brad go to the store to buy some laundry detergent for a neighbor. They see the same brand that she wants comes in two different sizes, 26 ounces for $9.75 or 20 ounces for $7.25. Which size should they buy? What's the best buy? Unit rates will help us solve this type of problem. Think about it for a second, make a prediction for yourself, and see if you can come up with what you might think. All right. Activity 2.1 here, just to get started, it says, as you learned previously, a rate is a ratio in which two quantities being compared are measured in different units. A unit rate is a comparison of two measurements in which the numerator and the denominator has a value of 1 unit. So getting one of those terms down to 1. One way to compare values of items is to calculate the unit rate of each item. All right, we're going to skip the rest of this activity 2.1. I just wanted to get a definition to show you what a unit rate is. Let's skip down and let's get to 2.2, activity 2.2, writing unit rates. And that's on M2-189. Okay, unit rates can be written with either quantity as the unit. So we're trying to get one of them down to 1. All right, so you can write every single ratio as a unit rate in two different ways. It says each situation relates a quantity and a price. Calculate the two different unit rates associated with each situation, price per item and number of items per dollar. For this, I'm going to let you use a calculator. So if you don't have one, why don't you go ahead and pause and go grab yourself a calculator. It'll just make for a little bit easier calculation, not having to do everything by hand. We're not going to do all of these, but we are going to pick the first two to look at. So let's look at this first one. It says a bottle of vitamins, of 250 vitamins, costs $12.50. So let's write that as a ratio. We have 250 vitamins for $12.50. All right, now we could figure out how much money does one vitamin cost. That's setting up a unit rate. We could also say 250 vitamins for $12.50. We could say how many vitamins do you get if all you want to pay is $1. Both are unit rate ratios and both can be calculated. We can figure out what they equal. To do that, all we have to worry about doing, let's change our color here, a little variety. We look at these as being equivalent ratios. So to go 250 down to 1, we scale down and we divide by 250. And we divide the bottom by 250. And if we take $12.50 divided by 250, we end up with 8 cents. So we can buy one vitamin for 8 cents. That is the unit rate. With the other one, 250 vitamins for $12.50. How many vitamins can you get for $1? Well, for this one, to scale down, we would divide by 1250. So we divide this by 1250. And if you punch that into your calculator, 250 divided by 1250 is 20, I believe. So I can get 20 vitamins for $1, or I can get one vitamin for 8 cents. I've calculated the unit rate. Okay, let's do one more here. You go buy a bunch of batteries. You can buy a 40 pack of AAA batteries for $25.95. So you can get 40 for $25.95. So we can ask ourselves two things. How many batteries can you get for $1? Or 40 batteries at $25.95? How much would it cost for one battery? So two separate unit rates that we can calculate, and we do it the same way we just did the last one. So to go $25.95 down to 1, we'd scale down by dividing by $25.95. And if we do that, 40, punch that one into my calculator here, 40 divided by $25.95 is $1.54. Or not, excuse me, you can get 1.54 batteries for $1. That doesn't quite make sense because you can't have a portion of a battery. Maybe this other one will make a little bit more sense. If I take this one and I divide by 40, can you hear the dog barking in the background? If I take $25.95 and I divide that by 40, I get, if I round it, 65 cents. So basically I can get one battery for 65 cents. This one makes sense. This one doesn't because I can't have a 1.54 of a battery. Correct? Correct. Also, in this first one, I'm only looking at the best deal because I can't just go buy one vitamin and I can't just go in and say I only have $1. And so we do this when we compare different sizes of containers. Let's skip down to, you can try these next two on your own, but let's skip down to number 2. It says not all unit rates involve money. Write 2 different unit rates associated with each situation. Okay. So in this one it says the 5 goats eat 20 tomatillos. Tomatillos, they look like little green tomatoes kind of. So we can write that as a ratio. We can say 5 goats eat 12 tomatillos. Okay. So we could say how many goats would eat 1 tomatillo, or we could say 5 goats, 12 tomatillos. If you had only 1 goat, how many tomatillos is he eating? All right, well, that would probably make more sense because we are going to figure out how many goats eat 1. I don't know if the goats know to share, if they're going to share equally. So let's see what we can figure out here. If we go to this first one, we can divide by 12. And if we take 5 divided by 12, we get 0.41 goats. Well, that doesn't make much sense, does it? But on this other one, if I have 5 goats and I get it down to 1 goat, so if I divide each one by 5, 12 divided by 5 is a 2.4. So each goat eats roughly 2.5 tomatillos or 2.4 tomatillos. This one would make more sense. Let's try B. It says the exchange rate. If we're going to exchange US money for euros, or if we're going to Europe to go traveling, we can get $10 for every 9 euro. Okay, so what's the unit rate? We could ask ourselves, how many dollars can we get for 1 euro? And over here we could say $10, 9 euros. How many euros can I get for $1? Okay, so let's figure this one out. If I divide by 9, and I divide by 9, we know that 10 divided by 9 is 1.1. So I can get, if I had 1 euro, that's about $1.11 US money. put my $sign at the end because I don't have any room. And on this top one, if I divide by 10, well, then I know that for $1, I can get basically 0.9 euro or 90 cents. I don't think it quite goes like that, but you can get 90.9 euro for $1. All right, let's skip the next two. You can try those on your own. It says number 3, for each part of question 2, identify which unit rates are useful in discussing the situation. Okay, so it says the unit rate needed to solve a problem is often asked for in the question. So for each situation, identify the unit rate that would answer the question. Explain how you decided. So it says, how many tomatillos did each goat eat? Each goat. That means one goat. So that's telling us they want the unit rate that gets us down to one goat. So if we go back up here, we would want this unit rate. One goat can eat 2.4. Let's write eats 2.4 tomatillos. And we also did B, about how many euros is each US dollar worth? Each dollar. So that means we want the US dollar to be the unit rate of 1. So we want to use this one because this one has 1 US dollar. We said that's about how much euro. So we can say $1 equals about 0.9 euros. We could round it to 1 euro, so kind of showing that it's a 1-to-1 ratio. Good. Moving on. Let's using unit rate to determine the best buy. All right, we're going to the movie, people. And I'm gotta get popcorn if I'm going to the movie. Movie theater popcorn is sold in large quantities. I think you can even go to the theater, or when it was open, you could go and get the very largest one, and then we give you free refills. So if you had a lot of people with you, probably your best deal. At this particular movie theater, they don't have that deal. They've got different sizes for different prices. And the smallest size popcorn usually contains at least 2 servings of popcorn. When you're eating all that popcorn, you have to get a drink. So we want to compare the prices for the various sizes of popcorn sold at the local movie theater. We want to know the unit rate of price per ounce for each bag of popcorn. Per ounce means we're going to get it down to 1 ounce. That's what we're trying to find. Why do we want to do that? Because we want the most for our money. We want to try to get the most popcorn for the cheapest amount of money. So let's see if we can figure it out. Let's start with the mega bag. You've got 32 ounces for $10.24. And they want the price per ounce. So they want to know how much for 1 ounce. Okay. Then you've got the giant bag for $6. And again, they want to know the price for 1 ounce. Then you've got the medium bag, 16 ounces for $4.48. And they again want to know how much for 1 ounce. And finally, the kids bag. You get 8 ounces for $2.40. Cheapest for sure, but it's not that much popcorn. And they want to know how much per ounce. So again, you can use your calculators on these. And so to get down to 1 ounce, we're basically going to divide by the top number. So we have $10.24 divided by 32 ounces gives you 32 cents 32 cents for that bag. Not bad. We go on to the second one, and we divide $6 by 24. So we have 6 divided by 24. This one costs 25 cents. 32 cents, 25 cents. I think this is a better deal so far. Well, next one, we're going to divide by 16. So we're going to take 4.48 divided by 16. This one is 28 cents. Ooh, 25 still is beating that one. Let's look at the smallest one. We're going to divide that by 8. And we're going to have $2.40 divided by 8. This one is 30 cents per ounce. Your best deal is going to be the giant bag. I wonder if that's the same prediction you made for which one was going to be the best price. Usually, the bigger the sizes, the better the value. Wasn't quite the case in this one. The mega bag didn't have quite as much bang for your buck, so to speak. But generally speaking, the larger the amounts are usually a better deal. That's why you have places like Costco where you can go buy a large amount of something and makes it a little bit cheaper. All right, you can try this detergent one on your own. We're going to skip that one. And I'd like you to go down to 2.4, activity 2.4. It says the local paper published these rates on gas mileage for a few new cars. I want you to ask yourself something. We're going to try to figure out which car is better. And do I want the car with the lowest unit rate like I did with popcorn bags? All right, so we're going to find unit rates again. But this time, am I looking for the one that has the cheapest or the smallest number? Well, let's see. So we've got 3 different types of cars. We've got the Avalar, the Centaur, and the Comstar. And we know that the Avalar can go 480 miles on 10 gallons of gas. The Centaur can go 400 miles on 8 gallons of gas. And the Comstar can go 360 miles on 9 gallons of gas. We need to see which one has the best gas mileage. So we're going to come up with a unit rate so that it reports miles per 1 gallon of gas. 1 gallon of gas. Okay, what does that look like? Start with the Avalar. We write the ratio, 480 to 10. And this 480 is miles. And this is gas, gallons of gas. And we need to know, we want to get it down to 1 gallon of gas. So 1 gallon of gas. That's how we set it up. In the Centaur, the ratio is 400 miles for 8 gallons of gas. Again, we want to get it down to 1 gallon of gas. And the Comstar does 360 miles on 9 gallons of gas. And we want to know how many miles does it do on 1 gallon of gas. Once we know that, we can decide which car we want. Okay, so for this first one, we will divide by 10 to get our unit rate. So 480 divided by 10 would be 48. We could probably do these in our head without our calculator. For this one, we want to divide by 8. So 400 divided by 8 is 50. And this one, we're going to divide by 9. We're going to take 360 divided by 9 to get 40 gallons. So the Avalar gets 48 miles per gallon. The Centaur gets 50 miles per gallon, and the Comstar gets 40 miles per gallon. Which one is the best car, the best mileage? What do you want to achieve? Do you want to try to go as far as you can on as little of gas as possible? Probably, right? Let's answer these questions. It says, how did you calculate the unit rate? Well, if you didn't notice, in every single one, we took the miles divided by the gallons. Miles divided by gallons to figure it out. We divide it by our top and our bottom to get our equivalent ratios. It says, how can unit rates help you compare these cars? Well, if we can get it down to miles per gallon, so knowing miles per gallon for gas helps us pick the car with the highest miles. All right, so definitely if I'm going shopping, I'm choosing the Centaur because I can go on 1 gallon of gas, I can travel for 50 miles. This guy ran out of gas, and this guy ran out of gas a long time ago. I can go a little bit further, which means I can go further for my money. That's definitely the one I want. Let's try 2 more on your own. I want you to try number 5 and number 6 on your own. Try to find the unit rates to figure out who's the fastest runner and who can make more cakes. Pause the video now, do some calculating, and then meet me back here to discuss. All right, hopefully you took some time on your own to answer these questions. Let's see what we came up with. We have Kalida can run 3 laps in 9 minutes, and Sonia can run 2 laps in 7 minutes. Who's the faster runner? Well, I think on this one, I want to set up my ratios, 3 to 9 and 2 to 7. And I want to know how long does it take them? Who's the fastest runner? If they're only going to run 1 lap, okay, so this is laps and minutes, laps and minutes. If they're only going to run 1 lap, have 1 big race, I want to know who's going to come in first. I want to know who can run it in the least amount of time. So I am going to divide by 3 and divide by, oh, not 3 though. I'm going to divide by 2 on this one because I want an equivalent ratio, remember. And 9 divided by 3 is 3. So Kalida can run 1 lap in 3 minutes, and Sonia can run 1 lap in 3.5 minutes. So who is the faster runner? Kalida. She finishes in 3 minutes, half a minute sooner than Sonia does. And number 6, Peter and Caillou are making mini cakes for the school bake sale. Peter can make 5 mini cakes. Oops. Peter can make 5 mini cakes in 25 minutes, and Caillou makes 3 mini cakes in 10 minutes. If they both continue to make mini cakes at the same rate, meaning they don't get tired or anything like that, and they go for the same amount of time, who at the end will make the most cakes? So finding a unit rate will help us here. Let's start with Peter. He does 5 cakes in 25 minutes. And Caillou can do 3 cakes in 10 minutes. Now, if I knew how long it took him to make 1 cake, I think then I can better figure out who's faster. So I'm going to get it down to 1 cake and 1 cake. And let's see, Peter, I would divide by 5. So 25 divided by 5 is 5. So Peter can do 1 cake in 5 minutes. Pretty good. And Caillou, I'm going to divide by 3 and divide by 3. And Caillou, 10 divided by 3 is a 3.3 minutes. So Caillou can make 1 cake in 3.3 minutes, and Peter makes it in 5 minutes. Who will make more cakes? Oops, not Peter. Just playing catch my mistakes. If you guys are paying attention, I think Caillou is definitely going to win this because he can make a cake in 3.3 minutes, which is super fast. I think he wins the Cape route. All right, use this information on unit rates to help you figure out your next clue for your Rogue Runner. And we'll let you know what your assignment is.